Okay, continuing with the final page. Let's see, we've learned how to name things. If something has a charge in it, it is an ion. So the name is going to have something ion in it. If it's a positive ion, which they call a cation, versus a negative ion, which they call an anion. Now I remember that because cation looks like it has a plus sign in it. That's the generic word for a positive ion. So this is a cation, a cation, a cation, and this would be an anion. Okay, so that is potassium. The question is, since it's a positive ion, we've learned that the periodic table has that section. There's the first two columns, then it has that middle section, and then there's some other columns out here. That middle section right here, those are transition metals, and they need a Roman numeral. Well, potassium is in this column here, so that's not the case. That would just be potassium ion. Copper, on the other hand, is right here on the periodic table. That is a transition metal. So I need to state what charge it is. In this case, it's positive 1. So that would be copper 1 ion. This also is copper, a form of copper ion, in the transition metal section. So the charge on this one is 2. Copper 2 ion. Notice, it doesn't matter what that's going to be stuck to later, because the name of this has nothing to do with what it's stuck to. The name of this ion only has to do with what the charge is. Here's P-3. It's an anion. So the anions, we've learned, you change the ending to "ide" and you put the word ion. Now zinc is a transition metal. So it should be zinc 2 ion. Now, if you did the homework on Thursday and read it, you realize there's a couple of transition metals that are exceptions. Zinc only makes a +2 ion, as opposed to copper, which can make either. So zinc, since it only means 1 ion, you're actually supposed to know, leave that charge off and write zinc ion. And then you're just supposed to know, almost like it's in column 2, that zinc ion is a +2. I will write that exception on the board so that you don't have to memorize it. Zinc ion is an exception, as well as silver ion, which is +1, and cadmium ion, which is +2. Those are the 3 exceptions to the transition metals need Roman numerals. Okay, next, right here. Now we have something that's not just an ion. It's atoms that are stuck together. So we have 2 different rules to name things. Actually, we have 3 different rules in our class to name things that are stuck together. If it starts with a metal, in this case phosphorus, which is not a metal, then we do not worry about the charge or how they share. In fact, if it starts with a nonmetal, they aren't charged, because phosphorus and oxygen would repel each other if they were ions. They must be sharing electrons, so that is how many of each diphosphorus. Di means there are 2 phosphoruses, and 5 is penta. And if you have an A next to an O, you sort of leave it off. This non-metal method of naming tells you how many of each atom. This is also non-metal. So that should be monosulfur trioxide, but they've decided if the first one's mono, you leave it off. So that's sulfur trioxide. This one is non-metal, but it's only carbons and hydrogens. So there's that little different set of rules we called organic. That would be methethpropbutane. And this one are both nonmetals. It doesn't have H's, so it can't be organic. And that would be carbon monoxide, because I wish it was monocarbon monoxide, but they don't use mono on the first one. These are both nonmetals, so that would be dichlorine. Remember, the first one gets its complete name, and the second one gets the "ide" ending, so pentoxide. Okay, let's look at this next row. Now we have a situation where you have metal, nonmetal. Okay, that means it must be made of ions. When you name ions things, you refer back to what we did on this top row here. If something is potassium ion, it's just called potassium ion. I don't care if it's ions that there are 2 potassiums and 1 sulfur. That doesn't matter at all. I need to know that this thing actually is made of 2 potassium ions and 1 sulfide ion, because when you name ionic things, you don't worry about how many it took to add up to 0. You just name the first guy. It's almost like first name, last name. This is potassium, and the last name, sulfide. And I don't care about how many each it took to add up to 0. Same thing would be true here. That's going to be aluminum plus 3 and sulfide, which is minus 2. And aluminum is not a transition metal, so aluminum plus 3 is just called aluminum ion. Aluminum. And S minus 2 is called sulfide. Now here's a situation that's different. Iron is a transition metal, like copper was up here, which means it can have more than one charge. Well, which charge is it? Well, you'll always be able to tell what the charge of the transition metal ion is by looking at what it's stuck to. So this is iron with some positive charge, and sulfur, which makes a negative 2. Well, they must have added up to 0, so I can kind of go backwards and say that must have been a plus 2. So what is that called? Well, just like when we named copper ion up here, or copper 2 ion, that has a charge of plus 2, so that is iron 2 is the first guy, and the second guy is sulfide. Okay. Now let's look at this one. Well, once again, it's iron, so I'm going to have to figure out the charge. Sulfides are minus 2 each. Okay. So if you write it out long ways, you're going to have 2 irons and 3 sulfides. Minus 2, minus 2, minus 2. That's minus 6 altogether. So these 2 irons have to add up to plus 6, which means they must have been plus 3 each. Well, what do you call iron with a plus 3 charge? Well, that's iron plus 3. And what's that guy called? Sulfide. Notice the 3 has nothing to do with how many irons there were. It has to do with the charge of the iron. It's like first name was iron 3, second name was sulfide. This is nickel, not stuck to anything else, so it just must be nickel. Oops, N-I-C-E-L. Make sure you go E-L because that's a common misspelling. How about F2? Well, we learned fluorine sticks together by sharing 2 electrons. That's the most stable form of fluorine that you could find that is pure fluorine, and that gets the element name of fluorine. Okay. This nickel doesn't occur diatomic, so nickel means 1 nickel. Fluorine does occur diatomic, so if you write fluorine, you're supposed to know that means F2. Same with chlorine or hydrogen. Okay, now we get to another one. So now the question is, which set of rules is that? Well, that's Ba3N2. Doesn't look to be too much in focus. Over there. Barium is in column 2, right here. Oh, okay, means it's always a plus 2. I don't need a Roman numeral for that one, so this must be ions because it starts with a metal. So that's just going to be barium nitride. First name, last name. Titanium, on the other hand, occurs right about here, and it is a transition metal. So I'll need to figure out titanium's charge. Let's see, those were minus 3 each, so they better have been plus 2 each, or they would not have added up to 0. So that's going to be titanium, 2, and that's going to be phosphide. Okay, and I'll just kind of hurry through these last ones. That's manganese. Manganese is a transition metal, so oxygen's minus 2, that must be plus 2, so that's manganese 2 oxide. Here, these are minus 2 each, so that better be plus 4 or 1 out to 0. So that'd be manganese 4 oxide. That's gold, transition metal, so that's 9 at negative 3, that must be plus 3, so that's going to be gold 3 nitride. Here's a situation like one earlier. Those are minus 2, so that must be plus 3. Gold 3 oxide. Interesting. Notice This only had 1 gold in its formula, and it was gold 3. This had 2 golds, and it was gold 3. It doesn't matter how many it takes to add up to 0. You're just trying to find the charge of each individual for the name. This is tungsten. That's -3 for the nitride, so that must have been +3. So I'm going to go tungsten, 3 nitride. Both nonmetals, so I need to say how many of each. Diiodine, kind of interesting, there's a double I there. And there's 5 oxygens, so it'll be pent oxide. Nonmetal, nonmetal. 1 phosphorus, phosphorus. Don't have to put the mono. Trichloride. Okay, cadmium, transition metal. Oh, wait a second. It's one of the 3 exceptions. So even though that should be cadmium 2 oxide, I'm just going to write cadmium oxide because I don't need the Roman numeral. This one, the oxides are -2 each, so that's -4. So the chromium must have been +4. That's going to be chromium 4 oxide. And that's just neon. Okay. And the last little thing we did was sort of learn just kind of how the units work when something is a force. Earlier as I went over the test, we had the shirt, and we talked about force of attraction. So it seems to me that you should know what force is and how the units work. So we did a brief introduction to something that you should have learned in 8th grade. F equals ma. A was interesting, it's the acceleration. So I have enough information here to find the acceleration because it's how much the velocity changes divided by how much the time changes. So it looks like the velocity changed, let's see, that'd be 65 meters per second minus 5 meters per second. And that took 5.3 seconds. So the change in velocity was 60. I'll keep all those sig figs because it's subtraction. And that was 5.3 seconds. So if you take 60 divided by 5.3, you get 11 let's see, only 2 sig figs. You get 11 meters per second each second. Okay, if you know the acceleration and you know the mass, then you can figure out, well, somebody must have pushed that car. I can now figure out how hard the car was pushed. I'll finish this down here because I know this formula, 3.5 kilograms times 11 meters per second squared, because that's how we handle those units, and you get times 11, and I got 124 point something, only 2 sig figs. So I'm going to say 120, and the units will be weird, but wait a second, I've got 2 sig figs, I better underline that. So it's 120, the units come out kilograms, meters, kilograms times meters in the numerator, and second square in the denominator. And we've learned that has a nickname called a Newton. So the force must have been 120 newtons to cause this car to have that acceleration. Okay, and the last thing here is what happened to sodium. Well, sodium started off neutral, and sodium lost an electron to turn into sodium ion. Okay, now the water created hydrogen gas, which then lit on fire. But from the sodium's point of view, this is all that happened. An electron was lost. So what do you call that when you lose an electron? We learned that's called, and I hate to say it, but okay, never mind, I'm not going to. That's called oxidized. If you gain electrons, it's called reduced.